Physics at Work, 2nd edition, Book 5, Radioactivity and Nuclear Energy. There are 3 chapters in this book, which is divided into 8 subchapters. We are going to finish them in 3 cycles. Chapter 1, Radiation and Radioactivity. 1.1, X-rays and nuclear radiation. Let's begin. What is radiation? In general, the word radiation in physics may refer to 1. Heat radiation, which is basically infrared radiation. 2. Electromagnetic radiation, which refers to all electromagnetic waves, most of which are non-ionizing, but the X-rays and gamma rays are ionizing. 3. Ionizing radiation, which refers to dangerous radiations, including high-energy EM waves and nuclear radiations such as alpha, beta, and gamma radiations, and many others which are very energetic and may cause ionization of any molecules, including our DNA, which may result in health issues or genetic problems. Ionizing radiations include high-energy electromagnetic waves and the 3 main types of nuclear radiations. They may produce ionization of body cells, especially the DNA, which is an important part of the cell nucleus, which can cause serious health and genetic problems. That's why ionizing radiations are dangerous to living organisms. And yet, there are applications of ionizing radiations in medical, industrial, and other areas. 1. X-rays. A. Production of X-rays. When electrons emitted from a cathode, the negative terminal is attracted by high voltage towards the anode, the positive terminal. The electrons accelerate. When fast-moving electrons strike on a heavy metal surface, the kinetic energy of the electrons is converted into X-ray. In other words, X-ray is produced when fast-moving electrons are stopped by the heavy metal target. B. Properties of X-rays. X-ray was discovered in 1895 as an invisible radiation that can produce blackening of photographic film. Low-energy X-ray can penetrate flesh, but not bone, and are used for medical purposes. High-energy X-ray can penetrate metal. Long-term or strong exposure to X-rays is hazardous to health. Applications of X-rays. Applications of X-rays includes X-ray imaging, computerized tomography (CT scan), which produces a 3D images of internal structure from X-ray images of different layers. X-ray applications also include luggage and container inspection, industrial inspection of metal structures, and lastly, in archaeology, to examine the internal structure of artifacts without breaking them into pieces. 2. Nuclear radiation. Shortly after X-ray was discovered, Henry Becquerel discovered some uranium salt may produce invisible radiations, which can also cause blackening of photographic film. The following repeats the experiment.
We will use a radioactive source to blacken a photographic film. There is a dental X-ray film inside this sealed plastic bag. The bag also contains a developer and a fixer, so the film can be processed right after exposure. Put a small metal key on the film. Place a sealed radium source about 4 centimeters above the film using a radioactive source lifting tool. After 40 minutes, put the radium source back to its storage box using the lifting tool. Hold the film vertically. Release the developer and fixer by squeezing the liquid down. And rub the film for about 1 minute. Open the plastic bag and take out the film. Rinse the film thoroughly with water. Examine the film. Which part of the film is darkened?
The invisible radiation in Becquerel's experiment can penetrate an envelope, but not a metal key. The radiation is emitted from unstable nuclei, and so the radiation is named nuclear radiation. And the nuclei are said to be radioactive. Nuclear radiation is emitted spontaneously, which means in random and uncontrollable, by radioactive nuclei which are unstable. Nuclear radiation can be classified into 3 common types, namely alpha, beta, and gamma radiations. The former 2 are particles, while the latter is a high-energy EM wave, as you should know. Do check point 1 below.